Welcome back to Parting Blades Round 2. In the previous video I built this parting blade holder, hoping to use this 32 by 3mm parting blade. Unfortunately that didn't go as planned. The insert broke in the cut and made a bit of a mess, and it's here where I should have been more clear in the previous video. I want a tool that works for me, not a tool that I have to work for to make it work. I know that lower speeds, less stick out, oil or coolant all helps with parting cuts. But on a rigid and heavy lathe like this, there's no reason why I should have to compromise on parting cuts. Now that we know this tool will not do the job, I'll have to look somewhere else for one that's hopefully better. And so I happened upon this other slightly different parting blade. It's made by Iskar, the same brand as my other known good parting tool. I got it second hand, but I doubt it's ever been used. With it, I also got a box of inserts. Let's take a closer look and see what makes this different from the Chinese blade. First and most obviously, the pocket has a different shape. That's because this insert does have a positive stop. The back and bottom surface are both firmly supported when the insert is mounted. Remember, on the Chinese blade, it's just a wedge clamp that allows the insert to move back while cutting. The other difference is chip evacuation. The top surface of the insert is flush with the holder and followed by a gentle curve outwards. The Chinese blade has a direct angle behind the insert, possibly impeding chip flow. That's enough looking at it. Let's put it to work. Same piece of material that the Chinese blade broke on, and let's see if it can chew through it in one shot. The parameters on the box are pretty aggressive. I hope my lathe can push this. It's set up at 630 RPM, outside diameter is 75 mm, the feed is 0.15 mm per revolution. Now that's more like it. I really like how good the chip flow out of the cut is. That looks so easy, I'm pretty sure it can go faster. Let's try 800 RPM, 0.2 mm feed. I really should have a look at the VFD. It should be able to power this no problem. But look at the insert, no chips or problems. I've put the speed back at 630 RPM, still 0.2 mm feed. Let's go. Okay, so I've done some calculating and it turns out that the cut that stalled the lathe at 800 RPM needs around 4 kilowatts of power. This lathe has a 3 kilowatt motor, so it stalled. I'll have to keep in mind for future cuts to not spin the spindle too fast. But despite that, what a fantastic parting tool. I can run my lathe at maximum power into a parting cut. I like that. But I have a final challenge for this blade. This is a 100mm diameter chunk of stainless steel. I don't know the alloy, but it's probably 304 because it's not magnetic and it's not super hard or high nickel. This is the most difficult test I can throw at it. I will put a center in the end because I don't want this chunk to fly in my face if it goes wrong. And I will also use coolant because I would still like to use this tool after this cut. I will be cutting at 250 RPM, 0.2 mm feed rate per rev, which should be pretty close to 3 kilowatts of power. Not quite one shot as I had hoped, but I'll take it. I had to speed up the spindle towards the center to make the insert cut better. At the end of the cut, when I removed the tailstock, the part did shift in the jaws and started to rub the tool. That was pretty scary for a second. I don't see any way a different tool could do any better for me, so I'll call an end to my search of a better parting tool. I will, however, be remaking the parting blade holder. It turns out these ISCAR tools have a slightly different center height than the Chinese ones. Also, I want to make the next one a little more beefy and heat treated. Alright, that's it for this one. Thanks for watching and see you in the next video.